Welcome, everybody. Thanks for joining us today. We are on our eighth episode.
Eighth episode, season 4.
Season 4.
Yep.
Yes.
Second to last episode, the penultimate.
I know it. I don't know. Where have we been? What have we gone over all this time?
It's been a lot of stuff.
Yeah.
It's good stuff.
Yeah.
And you can go back and find it on YouTube, which is good.
That's the best part about it.
If you missed one, you can always go back.
That's the best part about it. So, for those that don't know who I am, I'm David James, property training manager here at CNC. This handsome fella next to me is Murphy Buggs. Today's episode, our topic is going to be about common flooring material, from the installation of it to the repairability and failures in between that.
Yeah.
We partnered with an expert today. His name is Erik Moore. He's with EFI Global, and he is a respected expert in his field. He has lots of experience. The knowledge just oozes off of him. I try to get as close as I can to him when I'm around him so it'll drip off on me. So
Yeah. Well, and, we partnered with him at NACA for a couple classes. The National Association of Catastrophe Adjusters, NACA.
Yep.
Yeah, that was in Las Vegas. So we partnered with him for a couple classes. One of the main ones, the one that I was a part of that I really enjoyed was pipe breaks and pipe freeze failure and those sorts of things, which was fantastic. I think this is a class he also did at NACA, but I wasn't able to attend that one, so I'm really looking forward to this one.
Mm-hmm. I think we got some. I know we got some really good feedback from it. I know the participation in that class was really good.
I know the class I was in with him was a full house.
Mm-hmm.
I mean, it was a really good class, so I'm really excited about this.
Right. This topic, I mean, it's common in our estimates as far as as far as an estimating standpoint.
Yeah, on the flood and the property side. It doesn't just equate to one or the other.
Right. I'm excited to hear what we have to say or listen to what actually Erik has to say. Erik, are you with us?
Yep, I'm here and ready to go.
There you are.
Hey, Erik.
Thanks for being here. We're going to turn it over to you.
All right, guys. Well, let's get started. We only have an hour, so I don't want to waste too much time. So we'll jump right into it here. I have it split up into two parts. We're going to talk about tile flooring first, and then we'll pick up with the wood later on. But on the first part with the tile, we're going to talk about the material, some industrial guidelines and installation, talk about movement joints and typical failures that we see. And then on part 2, we'll look at wood flooring, the installation and failures of the wood floors. So with tiles, I separated it out into two separate materials. There's ceramic tile. That's usually made from red or white clay that's fired in a kiln. It can be glazed or unglazed with a nice smooth surface or not. And typically the glaze is what carries the color. It's waterproof. And the ceramic tile is suitable for light to moderate traffic. It's more prone to wear and chipping than the porcelain tiles. And it has a relatively high water absorption coefficient, which makes them a little less frost resistant. So maybe not outside up north. The porcelain tile is actually made from dust pressed from porcelain clays, and the tile is very dense, it's impervious, and it's very fine grained and smooth. The difference in between these two is when you chip a ceramic tile, the glazing is just on the surface. The color is just on the surface. So when you chip it, you're going to be down into the tile itself, and it'll either be white or that red clay. When you chip a porcelain tile, that color, because it's made of the dust, is going to be similar color throughout. So if you chip the surface, it may not be as noticeable from a cosmetic standpoint. And the porcelain tile is mainly for heavy residential or light commercial traffic, but tiles can be made of glass, marble, different kinds of stone, slate. Nowadays, with the recycling efforts, I've seen glass pieces, shards put together, all kinds of things that they can make tiles out of anymore. The industry guidelines, the tile installation is not controlled by the building code, since the building's not going to fall down. Nobody dies if your floor is not installed properly. So it's not part of the building code. It falls under these two books. The one on the left is the Tile Council of North America guidelines, and the other one is the ANSI standards, the American National Standard Specifications for installation of tile. These are voluntary guidelines. They're just guidelines. That's it. They're manufacturer specifications. These are, we'd like to see you do it this way, not like the building code where thou shalt, or the building code enforcement people will come get you and fine you and haul you away in cuffs. So that's mainly the problem with the installation, is there's no law, so to speak, to hold anybody's feet to the fire as far as installation mistakes, because these are strictly voluntary. I give you an idea of why tile's so popular. This is a life cycle cost from a few years back, but as you can see on the second line down from the top, glazed ceramic tile, the installed cost is about $7 a foot, but it's expected to last for 50 years. Whereas if you go down a little bit further towards the bottom, you'll notice carpet is a little bit cheaper per installed square foot at $3, but you're only getting a life expectancy of about 6 years. And in certain parts of the world, carpet's where everything goes to die, particularly in coastal environments with sand. You're never going to get the sand out of the carpet. So this is a typical sketch of how the ceramic tile is installed on a wood frame construction. One thing you got to be careful of with the tile over wood framing is the tile size versus the joist spacing. Typically, your joists are going to be 16 inches or 24 inches on center. So if you have a tile that is 16-inch or 24-inch, you don't want your mortar joints to align with your joist spacing. So when the floor deflects, that's where your cracks are going to show up and make them much more prevalent. We want to make sure our underlayment thickness is proper. We want to make sure that the deflection limits are met, like we are talking about with the joist spacing. In an 18-foot span, building code says we're allowed to have approximately a half inch of deflection there, and that's quite a bit of deflection in 18 feet. And because the tile is a rigid material, any little bit of deflection that we don't account for in the underlayment is going to cause problems with the tile and cause cracks and cosmetic issues and that sort of thing. So we want to make really good sure that we are taking care of those things in the planning stages and not after the fact. The movement joints, the Tile Council of America recommends an interior. We want to have a movement joint every 20 to 25 feet. If we're looking at sunlight or moisture exposure, they want it 8 to 12 feet. If we're going in the exterior, again, 8 to 12 feet. They like to see a 1/4 inch gap around the perimeter and restraining surfaces. So a little bit of a gap at the door jambs, at the thresholds, things like that. Um, a lot of times these aren't mandated, particularly in residential construction. If you see a control joint, a saw cut in a slab in a residential construction, it's usually just the contractor understands the concrete movement and puts it down properly. In Since they're not mandated, commercial construction, you'll see that a little bit more prevalent, and the movement joints are really common in commercial applications of tile. Anybody passes through the Atlanta airport a lot, they use these tile movement joints in an X pattern in a lot of the terminals, you'll notice. And the movement joints are slightly wider than your typical grout joint, which is why a lot of people don't like them, because that uniformity that you get from the tile grout, that movement joint is just a wee bit bigger, and it draws your eye to the difference, and it takes away from the overall aesthetic appeal. So that's why we don't see a lot of them. Here again, it shows you what they look like in the sketch. We want to have a bond breaker tape at the wall, a little bit of flexible sealant to allow for that movement, because the concrete and the slab are going to move at different rates. And we can't stop this movement with temperature. They're going to expand and contract differently. And similar to a paper clip, it's called a fatigue load. I can bend that paper clip a few times and get away with it. But eventually, the paperclip breaks, and that's what happens here. When we have a failure, you're going to have a catastrophic failure of the flooring, which we'll see here shortly. And on the right, you'll see that when we take the tile flooring over a building joint or a control joint in the slab, we want to make sure that we have some kind of flexible sealant there as well, because we already put the control joint in the slab knowing we're accounting for movement of the slab. So we want to make sure that we account for that movement in the tile as well, so not to have any issues or cracks in the tile above. I've seen plenty of times where the tile guy and the mason aren't on the same page, and they end up putting the ceramic flooring right over top of the building joints, and then they come back 6-8 months, a year later. Oh, why do I have a crack? I can't fix this crack. And we do a little bit of testing and pull up some tile, and well, there's a building joint here or a control joint in the slab. No wonder you have a problem. So all those things need to be taken into consideration during the layout. The Common failures of floor tiles. Typically, we get a non-bonded tile. The hollow sounds. I use a golf ball, drop it on the tile, and kind of bounce it around. You'll definitely get a distinct sound of a non-bonded versus a bonded tile. The tiles will tent. I've seen this manifest itself quite a few times. The tiles will actually buckle away from the floor slab, anywhere from a quarter to upwards of 3/4 of an inch. When this happens, a lot of times it'll happen in the middle of the night or early morning, usually between the hours of 11 p.m. and say 3 a.m. And people report to me that it sounds like gunfire or a crackling sound, something like that. You'll see a lot of cracked tiles, cracks reflected up through the tile from those aforementioned control joints where we tiled over them, and the chip tiles dropping things and impact damage. What causes it to fail? Well, a lot of times you can get a little bit of moisture on the tile, it's fine. But if there's long term moisture, that can cause you some problems. But usually the water itself, just because the tile gets wet, doesn't necessarily cause the problem. It's the temperature change, that drastic change in temperature that shocks the tile, either from a hot water release that causes the tile to rapidly expand, or from a cold water release that causes the tile to rapidly contract. That change in temperature is what causes the movement, not necessarily because it gets wet. But there's all kinds of different things that can cause movement. You can have foundation movement, you can have settlement, you can have impact damage. These are not necessarily causative, but they're directly related to the installation issues. I get asked the question all the time, oh, the flood caused my tile to debond. Well, not necessarily. The flood doesn't necessarily cause the tile to debond, but the flood water can infiltrate voids under the tile that were not caused by the flood. They were caused by these long-term movements in temperature exposure and things like that. So with a proper installation of the tile, we got to make sure the slab's clean, free of excess dust. You know how a construction site gets. Everybody's scheduled in there. It's tight quarters. The wallboard guys are in there. They're mudding and sawing. There's dust everywhere. The framers are still finishing up. You got some sawdust in there. All that's got to be cleaned off. The curing compound. That's one of the biggest problems that we've seen in recent years. Years ago when we poured a slab, the contractor would cover it with burlap, keep it moist, and it was what was known as a moist or a wet cure. Nowadays, we've given up on that, and we've gone to these chemical compounds that are sprayed over the slab once it's finished, and it seals the slab surface, holding the moisture in there for the cure. And that compound tends to be like when you wax your car. You can tell by taking some water and dropping it on the slab, and if the water beads up like it does after you freshly wax the hood of your car, you've got curing compound on the slab. If that water droplet is just flat and spreads out, there's no curing compound on the slab. That curing compound doesn't allow the mortar to adhere properly to the slab, which can cause bonding issues with your tile. The thin set mortar's got to be the proper consistency per the manufacturer specs. There's a lot of information on the tile boxes, on the mortar bags. Nobody reads it. They dump the mortar in a bucket, they spill some water in the bucket, they whir it up with a mixer. Yeah, that looks about what I'm used to, and off we go. Nobody pays attention to how much coverage is on the back of the tile, what thickness of the mortar should be, whether or not the tiles have to be buttered or not, where the expansion joints are going to be, what size trowel do we need when you're combing the tile, the thin set to set the tile, those little lines that you put in there. Those are certain sizes of those are used for certain types of tile, and that all has to be taken into consideration. It's not a one size fits all. And what type of thin set are we using? Do we need a latex modified for a little bit more movement, or can I get away with plain Portland? It all depends. Where are we putting it? What's the use? So the ANSI installation of the tile with dry set, it says to press the freshly combed mortar, the tile into the freshly combed mortar, making sure the contact with the tile. You got to have the joint alignment and spacing. Keep an adequate joint depth open for grouting. And they want a contact area between the mortar bed and the bottom of the tile to be 80%, at least 80% of each tile, but for exterior. If you're doing for shower installations or outside, they want it to be 95%. And we got to make sure that 95 or 80% is fully distributed across the tile to support it. We can't have it all packed on one side and a little bit on the other side that's not supported, because that'll cause you to have cracks when the tile goes into service. So we got to make sure that that's spread out. Give you an idea, everything expands and contracts. Ceramic is down towards the bottom here. If you notice, you've got your plastic, it has a lot of expansion, ice, of course, glass, copper, but your ceramic is very minimal with the expansion. Give you an idea of what we're looking at here. On a 50-foot slab, you're looking at a quarter of an inch, but again, it's rare that we're going to see that wide of an area, and that is strictly for the concrete. You're going to have a quarter of an inch of movement in the slab. With the hollow sounding tiles, this is what we're looking for. Typically, again, we're dropping them. When we start opening these up and looking, take a look at the coverage on the backs of these. They weren't properly set into the tile. If you note, or into the mortar, excuse me. If you look at the photograph on the left, you notice that you can still see those combing marks in the thin set from where the tile was, the mortar was combed, and then the tile is supposed to be set into the mortar bed and then pressed down firmly so that all those combing lines spread out evenly and adhere to the bottom of the tile. Well, clearly that wasn't done here. And you look at the tiles on the right side and notice that our coverage is virtually non-existent. I would call that much less than 50%. So that's why we have a debonding issue with this particular tile. And also notice that these came up relatively easily. They're all in one piece with minimal damage to the thin set. And again, you can look, these are some other ones that we've pulled up over the years. Again, they all have the same thing in common. You've got the combing lines in the thin set that are still available. If you notice the picture on the left, it actually has very little thin set. You can almost see quite a bit of the slab through the streaks in the thin set. So maybe this was an area where when they were installing the tile, they were running out of mortar, or it was the end of the day, close to lunch. They wanted to finish off what was on the paddle. And this was an ending point, and they kind of stretched it a little further than what they should have, and it led to some problems. But again, notice the coverage. This is half a tile. Both of these pictures are roughly half a tile with minimal to no coverage. So we definitely have some coverage issues with both of these installations. With the joints, again, these are really easy to spot. Against the wall, it's kind of difficult because the baseboard is in place, and then typically they put a shoe molding in front of the baseboard, that little quarter round piece, to hide the expansion or the gap at the wall. But the door jambs are the telltale. The door frames go all the way down to the slab, and the tile you can see in both photographs are tight up against the door jamb on the one on the left, and it's butted up tight. There's no gap. The one on the right, they've attempted to give a little bit of gap, but they've filled it with mortar. So again, we don't have any kind of area for expansion of the tile to allow it to move. What do the joints look like? Well, these are some different applications of joints. You can see the one on the left is where they've saw cut into the slab and extended it down several inches into the slab. The one in the center is typically the one that you see very prevalently. That's the one that's in a lot of the airport constructions. It's very simple to put down, but you notice it's a little bit wider and a little bit different look than the remainder of the grout. If you look at the photo on the right, you'll notice that you can very easily pick out where the expansion joint is in that field of tile. So that's one of the biggest reasons is why it's not used. People don't like to have that difference unless you have a tile layout to where you can mask the differences by including the joints in some sort of pattern. Now with slab cracks, typically, every slab is going to crack. We know that. The only concrete that hasn't cracked, the one you haven't put down yet. But typically when you put the tile over the crack, what you want to do is like what we have shown here. You want to isolate that crack with some sort of membrane. They have a tile, it's called tile isolation membrane, and it's basically looks like a big tape. It's about 6 inches wide, and they roll this piece of membrane out over the crack and attach it to the slab so that the slab can still move, expand, and contract along that shrinkage crack without having that reflect up into the tile. If the tile was rigidly bonded to the slab on both sides of the crack, that crack is going to eventually reflect up through the tile because it's rigidly attached, and the tile is a rigid material, so it's going to crack. Whereas if we isolate that crack and the tile is not necessarily rigidly bonded in this small area, we'll allow the movement of the slab without having problems above in the tile. Again, this is a little time consuming issue. It takes a little bit of know-how, and a lot of times it's not done. Again, you can see here, we've got the crack in the slab and the tape going in, a little closer view. So let's look at a few case studies here with some settlement issues. This one here in particular, you notice we've got the tile pulled up, but you see the big crack in the slab on the left. The photograph on the right of the plan kind of shows you the red line of where the settlement was occurring, and it's all along the issue because we had to backfill the back part of the house. In this particular instance, the front part of the house, as you can see, is roughly at grade and the back is elevated slightly. So we've got a little bit different foundation system that we're transitioning from front to back, and we end up with this type of situation. So how do we fix it? Well, if during initial construction, if the compaction of the fill is not done properly, you're going to have problems, and there's really no way to go back after the fact and fix it. So we have to install what are called underpins at periodic intervals around the slab foundation to essentially divorce part of the foundation from the supporting soil and provide additional support to eliminate that settlement. So what happens with the chip tiles? Well, this was a big thing about 10, 15 years ago. Everybody kept dropping cast iron skillets and pots and chipping the tile, and I need all new tile throughout my house. Well, if it's one tile, a lot of times, are there replacement tiles available? Some people have a box of tiles still laying around in the garage or up in the attic, some things like that. How old is the floor tile? Similar to a tile roof, can we match it? Are they still there? Look around too. Are there any places we can harvest a tile, say from beneath the washer and dryer in the utility room or the refrigerator or the range, something like that, or out of a closet where we can, take a tile out from those areas, replace it in an area that's seen, and then put maybe not an exact matching tile in one of those areas that's hidden from view. All you really have to do is saw cut the grout to remove a single tile and lightly hammer it till it releases, and then you'll prepare the slab and reinstall and regrout. If it's multiple tiles, that can be a little bit more tedious with, how much are we talking? And look for natural breaks, doorways, changes in elevation. Maybe one room is like 4 or 5 inches lower, so it's a natural break. Things like that. Maybe we have to do an entire room of replacement rather than just a single tile. So let's look at some case studies. This one in particular, this building was constructed in 95. The tiles were there when he moved in. During the night, they heard popping noises, and they woke up in the morning and found the tile sticking up in the air. No water leaks, no attempts to repair. So we get in and look, and this is a rough sketch of what the unit looks like. He's got some areas here, the hashed areas are where we found buckled and debonded tile, and the little squiggles are random cracks that are showing up through the tile as well. And here's what it looked like. You can see that the tiles are kind of TP'd or tented off the floor. They're up about 1/2 to 3/4 of an inch. They've released from the slab. But you notice they're nice and tight. Look at the door jamb on the right. They're nice and tightly installed there. They're nice and tightly installed at that nice tile baseboard at the wall. So there's absolutely no room for the tile to move, expand, and contract at all in this situation. So we were able to get one up, and you notice that we have virtually no coverage on that half of the tile that we were able to get up. So I would say, again, less than 50% coverage. And you notice with the exposed mortar bed, we see the comb lines in the mortar indicating that the tile was not pressed down firmly enough when it was initially installed. So what caused this? Well, it took a while for me to figure it out because this unit was located on the second floor, which was above the lobby area that you see here. And it was very interesting because normally if the tile's over an interior area, the temperature change is minimal. So there's something else going on. And while I was standing in the lobby looking at this, there's a large set of double doors behind me that opened automatically with a motion sensor. And every time someone walked past on the street, the doors would open up. Well, every time the doors would open up, if you notice the drop ceiling pieces there, you see in the upper left corner of the photograph, there's a supply air grill. That was the duct system for the air conditioning system in the lobby that was directly below our subject unit. And every time those doors would open up with the motion sensor, the air conditioning would kick on and run for several minutes, and then it would shut off. And then somebody would walk by again, and the doors would open up, and the same thing would happen. And it would cycle several times. I was there maybe 20, 25 minutes, and it cycled through about 5 or 6 times. So then it's finally dawned on me that's what was going on. Is every time the air would kick on, we'd get this cold air burst through the ductwork that would chill the slab, then it would relax. So you're constantly having that cycling happening. And with the floor plan, the measurements indicated that the debonded areas were directly over areas of where this ductwork was. So there was your temperature change that correlated to the debonding tiles above. And again, when we were looking through it, a lot of his areas of tile, the continuous runs were 22 and 35 feet with no control joints. Again, we like to see the control joints at 20 to 25 feet. And that was the issue, was the installation issues as well as the air conditioning issues. So let's talk wood flooring here. With wood floors, we're going to talk the basic wood materials, installation methods, and failures. There's a lot of different types of wood flooring out there. The solid hardwood, usually find this in a lot of higher end applications. It's typically planks, usually 3 inches or more in width. The strips can anywhere from 1.5 inches to say 3 1/4. They're usually fairly thick. They're usually, in excess of 1/4 inch thick. And then you have your parquet flooring, which is laid in blocks to form a decorative pattern. Typically, they're 6 inch blocks. They can go up to 36 inch square units, and they form those cute little square patterns and very decorative. With this type of flooring, we don't want to put it below grade. We want to keep it above ground for obvious reasons. It can be nailed, glued, or stapled to the subflooring or slab, depending on how thick it is. And the good thing about solid wood flooring is typically we can sand it and resurface it several times. Normally, you can get away with, depending on the depth of the discoloration from the damage, at least 2 times, depending on the quality of the floor and how overzealous your finisher gets. This is a very expensive product, but it typically keeps its value and it lasts the longest of other wood flooring products. Engineered hardwood, that's another product. It can be a plywood, it can be a hardwood, it can be a veneer over a high density fiber core. This is typically multiple layers, which each is called a ply, and they're oriented in different directions. So some go, north to south, the next layer might go east to west, and so on and so forth to give it a little bit more strength. It's glued under pressure, and that allows for greater stability. So it's less susceptible to shrinkage of, say, normal wood that's going to expand and contract with moisture and things of that nature. But it also makes it very difficult to repair. The installation of this product, it can be nailed directly to the subfloor, glued directly to the subfloor, or it can be floated where it kind of snaps together. This stuff is usually on the thinner side. I would say it's anywhere from 1/4 to maybe 5/16 in thickness. It's not nearly as thick as what you're going to see in the natural wood floor planks that we talked about earlier. And every one of the planks are going to look relatively uniform because it's a veneer, almost like a computer generated coating for the surface. So it's going to look very similar. Each piece will look almost like the other. It makes it very difficult to repair. This is a laminate wood floor. Again, this is a wood composite core with glue paper surface on top. The paper is essentially a photograph of what you want it to look like. It's very cheap. It's easy to install, relatively easy to clean, somewhat scratch resistant. You can't fix this stuff. Once it gets wet, what happens, it tends to curl around the edges, and this kind of debond that paper finish kind of starts to come off a little bit. And there's no sanding because there's nothing to sand. When you sand this a little bit, what you're going to end up doing is taking the photo paper finish off, and you're just left with that nasty wood core, which looks like pressed sawdust, and it's not any good. This stuff is basically snapped together or glued together. You can see in the photograph, it kind of fits together like a puzzle piece and is trimmed up. And you can always tell if your room is square or if the installer had a 3 martini lunch, because a lot of times this stuff doesn't always finish properly at the corner. You'll find is you get to looking really close. One side they start off nice and square and everything's even, and when they get to the other side of the wall, there's maybe a 2 or 3 inch difference from one side of the room to the other because the room's not quite square and they didn't account for that in the installation of the floor. Now, how do we put it down over a slab? This is kind of tricky. When you do a slab install, you want to have some sort of vapor retarder. Typically, they're going to put a vapor barrier on the ground surface prior to placing the slab, but you can't rely on that. So what they usually do is put down some sort of asphalt felt paper or building paper or some poly sheathing on the slab surface once it's complete, and then they'll put plywood on top of that vapor barrier and nail it directly to the slab. I've also seen it done with a screed system where they will use sleepers, they're called. Basically, it's furring strips, 1x material that is nailed to the slab surface after an application of mastic is placed down. And then they'll install the floor over it. So you have like a little cavity underneath the floor planks. Both of them have their advantages and disadvantages. The plywood issue and the screed system too, you got to watch when you're matching up different flooring materials, your elevation changes and things like that. So all things to be considered. You can directly glue the flooring to the slab. But again, the slab's got to be properly prepared. You can't have a dirty slab, just like we're putting mortar down for our ceramic tile. Again, follow the manufacturer's instructions for the adhesive. Make sure you have greater than 95% coverage on the back of the boards and it's equally distributed. So you don't have it. With a joist system, we got to make sure that it's the crawl space is ventilated. Typical code requirements, 1 square foot of ventilation for every 150 square feet of enclosed space. And it's got to be properly cross ventilated. We can't put giant 4-foot square openings in the perimeter stem walls in the back of the house and have no openings on the sides or the front and say, oh, we meet code, we have enough ventilated openings. Well, you do, but you don't have any provided cross ventilation. So just because you have the openings doesn't necessarily mean that the airflow is occurring in that crawl space. And I see this all the time. Over time, you may have enough ventilation for the crawl space, but the landscaping outside has matured and blocked vents, or the mulch has grown over part of the vents from repeated applications and things of that nature. People place things in the vents. They'll run cable lines and additional utility lines, maybe a gas line for the new range as an update, things like that, that tend to block some of these vents and cause problems. When we're doing it on a wood system, again, we got to put our vapor barrier down on the floor of the crawl space, and it's got to be properly installed up the walls and sealed around penetrations so that we're not drawing any moisture from the ground into that crawl space. And then we got to make sure we put, again, some sort of felt paper or building material on top of the subfloor before we apply our flooring material. Now, the floating method, this is typically for engineered and laminate flooring, the snap together stuff you get in the boxes at Home Depot. Again, these are elevated above the slab or the subfloor on a cushioned underlayment, and they're usually glued or clicked or somehow locked into position. Again, I see a lot of this in houses that are, for lack of a better term, that are flipped. Somebody buys them cheap. They want to put as little money in it as possible to hurry up and resell it. This, the laminate flooring is a good way to sort of kind of dress up the house a little bit, put a little lipstick on the pig, and get rid of it. It makes it look a little more higher end than it is. It hides a lot of damage, and we can make it look good until we're gone. With the flooring, particularly with wood floor, when you're using hardwood flooring, you've got to make sure that it's climatized properly. A lot of times the Wood Flooring Manufacturers Association recommends that the wood flooring come into the building where it's going to be placed and set there for at least 5 to 7 days to acclimate to the inside temperatures. It has to be, the building must be enclosed and it must be climatized. Otherwise, it doesn't do any good. What difference does it make if I leave the wood flooring out in the driveway or I put it in a house with no windows? It doesn't make any difference. It's not doing any justice there. Again, read the manufacturer's instructions that come with it. The environment that you're putting the wood into acclimatize should be near what it's going to be at occupancy. So if I'm putting this in a house that's going to be air conditioned, I want it to be air conditioned when I put the wood in there to climatize. I don't want to put it in there before we put the windows in or before the HVAC system is installed, only to have, 90-degree days on the Alabama coast and high humidity, and then we put the floor down and we have all kind of problems. What kind of material are we putting the wood over? Is it concrete and plywood? Is it over a crawl space? All those things got to be looked at. With concrete flooring in particular, I would recommend doing moisture testing on the concrete slab prior to the installation of wood floor. We see this all the time after the fact with damage. There's a lot of moisture absorption or vapor transmission through the slab that nobody knew about. And the only way you can find that out is to do calcium chloride testing. And basically what that is it's a small petri dish of calcium chloride that you place on the slab surface, and then you place a small dome. It looks like a shoebox, but it's clear plastic, and it's sealed to the slab surface, and you leave that there for 3 days. Before setting this up, you weigh your petri dish of calcium chloride ahead of time. You set it under there, and then you leave it for 3 days. You come back and you weigh your petri dish of calcium chloride a second time. And there's a fancy math calculation that you do, and it tells you how much moisture is coming through the slab. And based on that information, you'll know what type of treatment to do to the slab surface to prevent damage to the wood floor, or if wood flooring is even appropriate for that particular application. So, what causes the failures? Well, a lot of times it's lack of climatization. People bring the wood in and they leave it out in the garage instead of bringing it in the house before they install it. The garage isn't air conditioned, so the wood is nice and expanded. It's wet, so to speak. It's got a lot of elevated relative humidity in it, and we put the floor system in, and then 2 or 3 months goes by, the air conditioner's on, everybody's doing good, and people start complaining about gaps in their flooring because as that wood begins to climatize to the new interior environment that it's in, it begins to dry out. And when wood dries, it tends to shrink and causes gaps between the planks. Relative humidity, again, that's an issue over crawl spaces in particular, where you have vapor drive coming from the crawl space and causes the wood to expand and buckle. The free water, this could be plumbing leak, dishwasher overflow, wash machine overflow, anything like that. Temperature issue, like we talked about with tile, that can also play a factor with wood. Installation deficiencies for certain can play an issue. And also foot traffic. You can see in the lower picture there on the left, the black streaks, that's all, that's a high traffic area that is just wearing out a little bit more so than the surrounding parquet because of that's the high traffic area, the place where everybody walks and things get dragged through and all that sort of thing. So what's the problem? Well, wood floor, the moisture is enemy number one. Most complaints we see about wood floor result in changes in the moisture content or from nearby wood products. What happens? Well, you can get gaps like I talked about earlier. The wood expands. It was kind of wet when they put it in. They didn't acclimate it properly. They put it in, it dries out, it shrinks. The cupping and crowning are very similar. The cupping is the outside edges of each individual plank will be higher than the middle of the plank. So you'll get kind of a concave surface. And that's usually indicative of moisture exposure on the bottom of the plank as the edges tend to expand outward and curl up. The crowning is just the opposite. The middle of the plank will begin to elevate in relation to the edges of the plank, and you'll get a convex surface. And that is indicative of exposure from the top of the plank, just the opposite of the cupping. The buckling, that can be just from a wide area of the wood that has expanded from moisture exposure. And just like the tile, it has no place to go except up, and it'll tent upward, kind of like a speed bump. And then, of course, deterioration is just your normal long term repeated moisture exposure that causes rot. So, where does the moisture come from? Well, relative humidity, you get excess relative humidity from the air. It's going to absorb the humidity, the water vapor, until it reaches equilibrium, and then it'll be okay. But when is it the minimum relative humidity is when the wood's exposed to drier air. Then it's going to remove moisture. So you're going to have that fluctuation of expansion and contraction. Water release. Well, what happens there? Well, you get isolated, widespread plumbing failure, flood, all that kind of stuff. The exterior moisture intrusion. Maybe the floor system that we're talking about is at grade or below grade, and they're getting some backsplash from the gutters or some seepage at the base of the wall. Maybe there's an issue with a leaky window. You're getting some moisture intrusion around the window, and it's causing problems on the floor below. Or I see this a lot with French door assemblies. They'll have issues at the center of the French door assembly where the two panels come together. There's usually a little gap there from installation and usage, and you'll get some wind-driven rain through that gap, and it'll cause a little stain right in the middle of the French door opening. Anything like that could be moisture from the exterior causing problems. So let's take a look. Here's those gaps we were talking about earlier. The shrinkage. Gaps are normal, properly manufactured and installed flooring. It's just the nature of dealing with a natural product. You can expect shrinkage during the drier months or dry conditions. So, if you're up north, typically you're going to see this in the winter months when the heat's running up there. It's drying out the interior environment and causing the wood to also dry out and shrink. These gaps will typically go away in the summer months up north as the relative humidity creeps back into the interior and the wood absorbs the moisture and it slowly expands. It'll fill these gaps back up. Just the opposite happens down south. A lot of times we'll see issues in the summertime with gapping because the air conditioner is running down here and it's pulling the relative humidity out of the air and therefore out of the material and causing the shrinkage and vice versa. A lot of times these are minimal gaps, hairline, maybe up to a quarter, the width of a quarter, nothing too terrible. Installation related to gaps. Yeah, if the thing's not properly climatized, like we talked about, or it's a little moist and when they installed it, it's going to cause problems. Or if they put it in on a wet subfloor, that's going to cause problems. I see that a lot. The construction scheduling gets a little goofed up and they get ahead of themselves and hey, go ahead and put the floor in before we put the windows in, and it rains or something like that happens. That'll cause you problems. The newer building practices with the green the green wave, they're leading to a tighter building envelope, which will hold in that construction moisture. So any type of moisture that's in the building during construction is going to get trapped in there. It's not going to be able to get out because before the building wasn't as airtight. You had a little bit of drafting and you could release some of that moisture. But the moisture content measurements can help determine whether or not those gaps are legitimate from some sort of moisture release or something else going on, or if it's just an installation issue. The cupping, you can see in the photograph below, that's what I was talking about earlier with the edges kind of expanding and rising up in relation to the center of each plank. This is the moisture is on the bottom exposure, either from the crawl space ventilation from a vapor drive issue or any kind of water release that maybe has gotten on the slab and flowed into the area where the wood floor would be. This causes the back of the wood, the underside, to expand wider than the top side, and that results in the raised edges of the slat. Usually this condition is the flooring is tight, and a lot of times if you dry the flooring out, this will slowly go back down if it's from a one-time release. If it's a vapor drive issue from, say, a crawl space ventilation issue or something of that nature, then you have to correct the ventilation issue, and over time this will settle back down. But again, in this type of flooring application, we can sand this lightly and do a little refinishing and knock those high parts down, and it's okay. If we have to go, but we got to correct the moisture issue. You can see in the picture in the upper right, that is your laminate flooring that I was talking earlier. When it gets wet, it's going to have those curled edges and puckered edges, and there's no repair for that. It's got to be replaced. Another complaint, the wood floor is acclimated to a higher moisture than when it was originally installed. During installation, the floor was dry. It got installed tight. Now it's getting wet. The floor expands due to the absorption of the moisture, and it causes problems. Again, same type of situation. We did everything right, but we put it in, say, over a crawl space that we didn't properly ventilate. And now we're getting some vapor transmission through and causing the floor to expand. And it's going to start to buckle because it is installed tightly. And the only unrestrained direction the wood has to move is upward, away from the floor. Complaints. I dried the floor. What do I do? Well, when you dry the floor and over dry it, it's going to shrink and it's going to lose moisture. The face of the wood becomes smaller than the back, and you'll start to show cupping again. Or you'll get gaps in between the planks, depending on how much drying you do and what type of system you're talking about. Whether it's a hardwood plank, a laminate system, or if it's on a slab or vice versa. And also, the biggest problem here is, again, you've got to mitigate the water before you start trying to do anything with the floor. The crowning, this is the flooring that loses moisture and shrinks on the underside and flattens out, and it leaves the edges of the floor lower than the center of the surface. This is it on typically see this on floors that are installed and sanded, because the high edges of the cup flooring are cut with a sander. The edges will be a little thinner. The underside is still cupped. When it acclimates, the edges sort of recede and it becomes lower than the center. So you kind of, what you did is over sanded it. Now you're going, you taken the high spots off from the cupping, and now we're going the opposite direction. So again, if you're going to do the repair, you've got to have somebody who is knowledgeable about what they're doing, and not just, some day laborer that they picked up to run the floor buffer sander, who they're going to turn loose in there and let him go to town and, well, just grind it down until you can't see the finish anymore. And the next thing you know, you've got a sunroof to the crawl space. The tenting, the buckling. This is definitely excess moisture in the flooring because the wood's expanded. It doesn't have any place to go but up, and you end up with like you have in the photograph. It's tented up like a speed bump. This abnormal expansion causes stress against the weaker, especially in the longer runs when it's improperly installed on the floor, and it'll start to pop up. You see this a lot, particularly in the longer runs. Think of it like a soda straw. If I had a soda straw vertically and I push down on the top of it, what's it going to do? It's going to buckle out from the side. Well, if I put my hand on one side of that straw and I still push down on it, it's only got one way to go. It's going to buckle out the side. It's the same thing here with the floor system, only the floor is horizontal, and we're squeezing that soda straw from the sides on the desktop. And it's pinched at the walls. It can't go anywhere. And it's going to pop up. So let's look at a couple case studies. Here we've got a quadruplex condo unit, got a musty odor, can't figure out what's going on. No visible defects to the floor. Everything looks good. Nothing's wet, nothing's swollen. Well, what's going on? So we start looking around, and we ended up doing some calcium chloride testing to remove some wood. This is what the test looks like. It comes in a little box like that. And you can see in the lower photograph, we remove some flooring. We got to remove as much of the adhesive off the floor as we can to get as much clean slab as we can. And we put the test box in and let it sit for about 72 hours, follow the instructions. In this particular kit, you can buy this from a third-party vendor, and they will send you the weight of the calcium chloride already. Then you package it up and send it back to the calcium chloride box back to them after your test is complete, and they will send you an email copy of the test results of what you found. The National Wood Floor Association typically recommends 1 to 3 pounds of water in a 24-hour period as dry. It means you have no problems. 3 to 7 pounds, they want some sort of moisture barrier, whether that is a liquid applied barrier or some sort of asphalt paper or whatnot. Anything over 7 pounds, they recommend that you rethink the choice of wood floor. I get into a lot of this issue where people say, oh, I bought this house and it for years. Well, carpet is okay in this situation because that vapor transmission with carpet allows the moisture to come through the carpet into the interior atmosphere and be diffused, evaporated. When you put the wood floor down over the slab, you've now effectively sealed the slab surface with that finished surface of the wood floor. So that moisture evaporates up through the slab. It hits the underside of the wood floor where the finish is, and it can't go anywhere. So it accumulates in the floor, and that's what causes your expansion, your discolorations, and all that kind of good stuff. So we did a calcium chloride test here. The lab results came back. We got over 10 pounds of water in a 24-hour period. We said, look, wood flooring in this application may not be what you need. You should remove the wood flooring and do some sort of other flooring installation, be that ceramic tile or carpet, or perhaps you can reinstall a wood floor after treating the slab surface with some sort of vapor retarding product, and if you want to chance it again. But you can't leave it as it is because you've got too much moisture coming through this slab at this time. Second case study, we got a 2-story house, damaged only on the first floor. It was built in '88. The original hardwood floors were damaged during Wilma in '05 and were replaced. The new flooring was installed in '06, and we were there in '11. The dining room, they hardly use it, but they thought the darkening floor was natural. They were a little concerned about what they were seeing. And again, no plumbing failures reported, no other visible moisture. So we go have a look, and this is what we see. And when I see this type of damage, I'm ultimately thinking almost initially of we've got moisture issues coming from below. And it's been there a while because this type of damage doesn't manifest over once or twice. This is a period of time, particularly in the lower right picture where it's very dark and deteriorated. That's been going on for quite some time. So again, we started looking. You can see in the close-up photos here the extent of the deterioration. I mean, this board is actually rotted from repeated moisture exposure. And, we've got the long-term exposure beneath the flooring. The rear sliding glass door face north. It's going to diminish the heat load to the dining room, warm up the floors, promote evaporation of the excessive moisture. Close proximity surface water drainage pond, landscape or sprinkler heads. We couldn't pull any of the top of the wood off to do a calcium chloride test, but they've obviously got some issues here going on with some elevated groundwater with the surface pond very close by. And I would also want to check the landscaping sprinkler heads that apparently these people were not privy to the controllers to make sure they're not spraying on that door and contributing any additional moisture from the exterior. This one's an interesting one. This is kind of like 2 different places. They were examined 3 years apart, both with laminate flooring. One floor was 6 months before damage was apparent. The second one was 4 to 5 years before we got there. And they found the damage after rearranging furniture. They've got cupping of the edges, deterioration at regular intervals. One floor was installed over terrazzo, one was installed over concrete. Of course, the leak detection company comes out, doesn't find any problem, no increase in water usage, anything like that. So we go look. And you can see we've definitely got elevated moisture. You can see the puckered edges of the laminate flooring. The lower right photograph shows you some deteriorated laminate flooring that's in really bad shape. Here's some more pictures. We started to cut into the underlayment a little bit to see what's underneath. You can see the large areas here of terrazzo. So when we check these all out, basically the problem is they've got issues with the water transmission from below. The terrazzo helped a little bit, but primarily the issue was, again, we want to do more calcium chloride testing to find out where the water, how much water is coming through, and whether or not wood floor is the predominant proper application there. In number 4, this one's kind of similar. Again, this is a situation, the current owner, the floor was installed prior to purchase. The wood's soft underfoot, discovered in the dining room, no water damage. They want to know, why is my floor soft? What's going on? So we go looking around, and you can see from this photo that we got the wood floor on the left. You got it on top of plywood. You've got a moisture barrier, and then you've got over the concrete slab. So it looks to be installed relatively correctly. you can see in the photograph that obviously we got some moisture going on. They were able to get up a section to show us. You've got a very deteriorated section of what appears to be OSB that is definitely rotted and deteriorated. And you can see from the moisture meter photograph in the picture that we've got a lot of moisture in the slab shown. You see the same photograph here. We got the wood floor, the moisture barrier, and the plywood or the OSB decking that's very deteriorated and darkly stained, obviously exposed to some moisture. And this, again, it's coming from the improper installation and the moisture transmission through the slab. And the reason it's soft underfoot is as that OSB is absorbing moisture repeatedly, wetting and drying, it's deteriorating and breaking down. So it's supporting your sections of laminated flooring. And as that deteriorates, the OSB deteriorates, the laminate's no longer being fully supported. So you're going to get some deflection when you impose a load with your feet walking across it. So that's why you end up having the soft flooring issues. So my wood's damaged. What do I do? Well, solid wood flooring, typically we can dry it out, sand it, and refinished. Research was done years ago by Dr. Ralph Moon at HSA Engineering, where they cycled through various sections of wood to show what happens when wood gets wet and dried, wet and dried, wet and dried. And as you can see, the solid wood, it behaves elastically, essentially. It's going to expand a little bit and return to virtually its same size every time it's wetted and dried. So that tells us that we can dry solid wood out and be fairly confident that it's going to survive. With the engineered wood floor, that's a little bit different animal. The ability to salvage that depends on what's in the core material. If it's a plywood core, depending on what type of plywood, interior versus exterior, we may be able to save it because the interior plywood and the exterior plywood grade have different glues that are used between the plies to make the wood. The exterior being a little bit more water resistant than interior. If it's got the high density fiber core, well, that's going to be a little different. Just like the MDF cabinets, when it gets wet, it's going to swell and it go back to normal. It's going to have a problem. And again, with laminate floor, typically any exposure to moisture is going to require removal and replacement. This stuff is just going to pucker, and cosmetically it's not going to look good. It's going to deteriorate, and it's going to require removal and replacement. So we covered ceramic and wood flooring. Thank you very much. If y'all have any questions, please feel free to open it up to questions with David and Murph, and we'll see what we get.
Yeah, thank you, Eric. Lots of takeaways for me. Lots of information. I can't begin to say how much, going back to the tile and all the way up to what you talked about as far as the material, breaking it down, the types of material, the way it's installed is just very, very educational. One of the themes for me was expand and contract, right? When you're talking about the material. I remember back when years ago, bought some flooring and brought it to the house and was ready to install it. It was like, wait a minute, and this goes back to your point of reading the manufacturer's instructions, is you have to let it acclimate to the area first instead of just immediately trying to put it in, So the temperature change for me was a big thing. I like the case study. That was very interesting with on the second floor with the tile and then the automatic doors. Every time somebody would walk by, it would open up, and then the air conditioner would kick on, and that was interesting. That would have been fun to look into.
That one took a little bit of figuring out because I was a little bit confused there. Like, what? I know something's going on. What's going on? And until I was standing there and got hit with that blast of air every once in a while, and it was like, wait a minute.
Yeah. I also found it interesting the guidelines for the flooring that you mentioned. I didn't think too much about it because I know there's a bulletin or a brochure out there for tile on the roofs.
Yep.
For the flooring, do you know if they do the same thing for, like, if tiles are discontinued? Do they have a bulletin added to that for
that? I don't know. I haven't seen anything about that. I do not know.
Okay. But it's a good references, of course, to go back and forth if you need to for those guidelines. I did like the makeup, the way you explained porcelain versus ceramic and how they're built, essentially, the chipping of it and the discoloration of it.
I like the Chipper 3000.
Yeah. So for me, it was very informational. I'm gonna go back and watch this video a couple of times, to be honest with you, because it was lots of very informative. That's all the comments, questions I had. Do you?
Yeah, we did have a couple questions come through in the chat.
Okay.
So, Eric, I'll read them to you. First one we have here is I have some tiles in my kitchen that sound hollow. Is that a dead giveaway that there is some kind of manufacturing error? Or is it possible that there's damage when you feel hollow tiles?
Well, are you feeling hollow tiles, or they just sound hollow when you tap on them?
Yeah, more the sound of them, yeah.
The sound. Yeah, it doesn't necessarily mean that the flooring is damaged. It just means that the areas that are sounding hollow are not rigidly bonded fully to the underlying substrate.
Right.
So those would be things that I would be concerned about if I'm, say, wheeling a dolly with a new refrigerator in. I try to avoid those areas if I could, because they may crack under the concentrated load of the dolly wheels and things like that.
Right.
They may be areas that might crack or wear prematurely. But as far as the repairs go, that's a tough one, because you're going to have to take the tiles up and back down, and matching if you break one and all that kind of good stuff.
Well, I liked how you mentioned, too, in taking them out of high visibility areas, maybe you can salvage one or harvest one from under appliances or, in a closet or something like that. That actually makes a lot of sense that some people may not think of. They think, well, this one's damaged. We can't match it. We got to replace everything. Well, there are alternatives to that, like you mentioned in your presentation. And then the second one we had here is, as a field adjuster, how can you, maybe not immediately, but how can you help to identify what type of wood flooring it is as soon as you enter a home? Like, are there some dead giveaways that you see, in your line of work that you can tell, yep, that's laminate, real hardwood, vinyl plank,
Well, the laminate's usually pretty easy to give away, because it's usually in the wider plank. Usually you're going to see that in like maybe 7 to 8 inch wide planks, usually very thin. It's typically less than 1/4 of an inch thick. And especially if it's gotten wet, it's going to have those characteristic puckering and rippling. It's going to show you all of its edges of all of its planks. That one's a pretty easy one. The engineered hardwood versus the planks, the real wood, the real wood should be easier. It's going to be thicker than anything else, and it's usually going to be smaller strips. Normally, you're going to see the strips like 1.5 inches, 2 inches wide, whereas the engineered hardwood flank is going to be more along the lines of the laminate, maybe 4 inches wide, 6 inches wide, that sort of thing. And it may not be as thick as the regular hardwood.
Gotcha.
In my experience, if I have a question about what it is, I typically just ask the owner, especially if they're the ones that installed it. They're going to know, and they may even have a box or two left laying around to help you.
That's right.
Yeah.
That's right.
Yeah. And then the last question we had here is, can staining on tile or other flooring be covered by a policy for tiles to be replaced, like shingles sometimes, since they can't match them? So I guess when it comes to this question, it's maybe not so much the water damage to it, but if they're stained, does that typically get covered under an insurance policy? Or?
Well, I don't do coverages. I would kick that back to the adjuster and the individual
That's what
policy.
we wanted to hear.
I wouldn't be able to answer that,
Right.
but typically in my line of work, I'm more over function versus form. So as long as the tile's still doing what it's supposed to do, and it just doesn't look right, well, that's it's still doing its job at that point.
Right.
It didn't compromise the integrity of it.
Yeah, and typically it is on the adjuster to determine coverage. Yeah. So
Yeah.
that's all the questions we
That's
had.
all we got.
Yep.
Good.
Oh, wow.
Good stuff. Good stuff. Well, thank you for being here. Thanks for the presentation, Eric.
Hey, glad to
like
help
always,
Yeah, we really
good
appreciate it.
information.
We really appreciate it.
Really good information. So, for those of you, don't forget, if you need to go back and see it, remember to visit our YouTube channel.
Yeah. On the YouTube channel, they'll all be in there. And even past seasons are on there, too. Not just this season. Yeah, so with our last episode coming up in 2 weeks, believe the title is "What is New and How Does It Concern You?" or how does it pertain to you as an adjuster? We're going to be doing that one too on Facebook Live again, just like we're doing this one. We obviously want feedback from our viewers. Let us know if you like this new platform. It's something we're looking into, and something we would like to transition over to, but also want to get some feedback from the folks that are attending, and basically who we're presenting to. Is this something you enjoy? This platform that we're using. So that's one thing I really wanted to mention before we let everybody go.
Right. What was the name of the last episode?
What is new and how does it concern you? So we're going to be talking about some new things that have come up over the last year, maybe new legislature, new estimating guidelines, things along those natures. So that's that's a quick tease for 2 weeks from now.
Yeah, interesting. 2 weeks.
Yep.
So what's the date on that?
That would be June the
8th, June 9th?
I don't have the calendar right
Something
in front
like
of me,
that.
but we can look.
Just remember 2 weeks.
Yeah,
right?
June 8th, yeah.
June 8th. I
Yeah.
thought it was June 8th.
2
So,
Thursdays from now. Yeah.
exciting. I think you and I are going to be handling that one along with probably a guest speaker.
Yeah.
Yeah. May pop in here and there.
That's right.
Okay.
That's right.
Awesome. All right. I don't have anything else. You got anything else?
Nope. I think
Okay.
I'm good. I always want to say this. Thank you to everybody that you can't see on this screen right here that makes this all possible. It means a lot. And obviously, thank you for attending.
Right.
Without you, we would just be talking to ourselves. So we appreciate you being here, too.
And thanks a lot, guys. Thanks for having me.
Eric,
Yeah,
it's
thanks,
always
Eric.
a pleasure.
You're the best,
Thank
man.
you, sir. All right, guys. See you in 2 weeks.
See ya.